Okay, so we want to talk about ecological characteristics of weeds. Here we've got a soybean crop with weeds. I hope you can see the soybean crop. And of course there are plenty of these weeds. The question is, what are weeds? That is the question we want to address. Kami. Yeah, I am having a lecture. Yeah. Okay. I'm not free. Yeah. Okay. Okay, we have got weeds in a soybean crop. So this is the soybean. In between, we have got other plants which are weeds. So there are several definitions of weeds. Okay, let me admit this.
Doc,
Hello?
is it possible if you can share the presentation in full screen so that we can clearly see the slides?
You are not seeing the slides?
Yeah, it's actually at the corner.
Okay, let me try to improve it.
Okay, thank you.
Okay, let me go back to the presentation, and when I project it, give me your views. I mean, how you are seeing it. Can you see this section on weeds?
Yes, Doc, it's on weeds.
Can you see what is there?
Yes, Doc.
You can see it?
Yes, we can.
Yeah, this is what I want you to see. Okay, let me go to the presentation. Assuming that we are all okay now. So, as I indicated, there are several definitions of the term weed. But the one we are going to use, I'm not going to bother you with these other several definitions. What I want you to use is this very simple definition. Weed is a form of vegetation It is a form of vegetation that is highly successful in agricultural environments. We are going to define what we mean by success of a weed or highly successful. All right? So the weed is a form of vegetation that is highly successful in agricultural environments. What it means is that you will always find these plants in agriculturally disturbed environments where we do a lot of plowing, weeding, because we are supposed to be killing these plants, yet they keep on coming. And it is these plants which keep on coming which we term weeds. So they are adapted to grow in highly disturbed environments. So weeds grow in environments disturbed by man without being deliberately planted. This is according to Baker. If we disturb the environment, we expect certain plants to come in. We call these pioneers of secondary succession. If we are talking in terms of ecology, we talk about pioneers. These are weeds which come. These are plants which come first. When you have cleared the land, you have left bare soil. The first plants to invade bare soil are known as the pioneers of secondary succession. This is an ecological term, and we are not going to worry much about it. What I have indicated in red is the definition which we will use. So let us look at the weed success in the agro-ecosystem. The definition of success, it may mean rapid colonization of disturbed sites. You find that when we have cleared a field, we always find the plants coming in, and we call this colonization, and it is happening very fast, rapid colonization. They are also difficult to remove. They can suppress the productivity of crops. These are the weeds. Now, from an ecological point of view, in order to really understand what weeds are, we need to look at the relationship of weeds and the environment. So we're going to look at the relationship of weeds and the environment, and to help us on this issue, we have got two approaches which were used to understand this relationship of weeds and environment. We have got 3 scientists, MacArthur, Wilson, and Pianga. The other 2 were working together in 1967 to study the weeds and the environment. Let me admit somebody. Okay, I've admitted somebody just now. Let me go back to where I was. So, in 1967, MacArthur and Wilson were studying the relationship of weeds and the environment. In 1970, also Pianga studied the relationship of weeds and environment. So what does the environment do to weeds, which is unique? These scientists came up with what is known as the R and K strategy. R plus K strategy. We want to find out what it is they were talking about. Then another one, scientists called the Grime, developed what is known as the CSR theory. Just in order to understand this weed and environment relationship. So we've got 2 approaches. Let us look at them. Probably some of you may be interested in ecology. So the theory of R and K selection. This is the strategy of evolutionary specialization. It's a mouthful of words. Evolutionary specialization. Maybe let us look at what R means. If we have R selected organisms, these are adapted for colonization and reproduction in disturbed environments. So you have disturbed environment, and these are adapted for colonization and reproduction. Where a lot of soil disturbance is taking place, like plowing, weeding, chemical application to kill some plants, but still you find the plants coming in. These plants can have what we call R selected organisms. So these are the R selected organisms, or the R species. They can occupy the early stages of succession, where a lot of agricultural disturbance is taking place. You find the R species. So in other words, R species are what we actually call weeds. So agricultural weeds seem to be the other species, according to Piaga and these other scientists. But if we look at the K-selected organisms, these are adapted for persistence and reproduction in stable environments. And what are these stable environments? If we look outside and we move in the environment or outside, we may just see plants which are always there. These could be grasses, these could be forests like savanna or just the trees which we always see. These are stable environments. These are not weeds. It's this other part of vegetation. And we say K species form the last stages of selection. In other words, if we move around, we see plants, which could be trees or grasses. These are the K-selected species. We can come in and clear the fields and do some plowing. The plants which come in are known as the weeds or the other species. So we just want to say that weeds can be the other species. And everything else which we see is the K species. So if we're drawing a graph, in the early part of disturbance, we see the other selected species here. That is where we see the weeds. Here we see probably trees plus grasses, which are not weeds. This is the stable environment. So weeds occupy, if we look at the time, they will occupy the early part when we have disturbed the soil. And the last part, when everything is stable, we get a K-selected population of plants. Let us look at Pfumvudza or conservation agriculture, where we are not disturbing the soil a lot. Do you think we are going to move the natural vegetation from other species towards K species? There are some people who are doing such studies. Now, let me look at the second approach. I've now looked at the first approach proposed by MacArthur and Wilson in 1967 and Pianga in 1970. Looking at weeds as other species and everything else as K species. That's what they proposed. Let us look at what Grime proposed in the CSR theory. Now, in the CSR selection, we will define what these stand for. We have got planned strategies of adaptation that define the role of environment in determining plant succession. So it is the environment which determine plant changes. These are changes. So there are factors which can limit plant material in the environment. Two things. There is a stress. There is also disturbance. Stress and disturbance can limit biomass. So disturbance is actually destruction of plants by men. And this stress factor plus disturbance will create 3 environments or habitats which will produce plants. Now I have got 2 things. Number 1 is intensity of disturbance. Here I've got intensity of stress. It could be weeding. This is stress. It could be plowing. Now there are 2 things, disturbance and the intensity of stress. Actually this could be moisture limitation here or soil fertility. Weeding, let us remove this from here. So this could be moisture. Okay, let me admit somebody. Okay, I have put the moisture, then fertility. This is soil fertility. Here on disturbance, let us put weeding and plowing. Right. So we can have a low disturbance like in minimum tillage, or high disturbance like in conventional tillage. Now, on moisture and fertility, we may have low fertility, we may have high fertility. Now, here we have got two things: low disturbance and low intensity of stress, which could be moisture or fertility. If we have got a combination of low disturbance and low stress of either moisture and fertility, in other words, we have got good conditions for the plant. We have what are known as the competitive plants, competitive strategy. These two factors produce the competitive strategy. This is how we can classify the plants. Now, if we have got a high stress, probably moisture is limiting, fertility is limiting, but there is also low disturbance, we end up with the plants. These are plants classified as competitive strategy. In here we have got plants classified as stress tolerant strategy. Then we come to the last line where we have high disturbance. This is where we are plowing. A lot of plowing, a lot of disturbance, but the stress is also low. For moisture, it means we have got plenty of moisture, plenty of soil fertility. We have got a ruderal strategy. These are the agricultural fields. This is where we find a lot of weeds. It's a complicated way of just saying in plowed agricultural fields, this is where we find weeds. But you are trying to create order in this environment. Then there's a place where you don't find plants, where there's no viable strategy. Probably these are deserts, where the stress is very high. There could be disturbance, but then you don't find plants there. So this becomes the C. This is S. This is R. This is where the CSR comes from. It's quite a big subject. So this is the CSR selection. It means we are creating different conditions in terms of stress and disturbance, and it produces certain types of plants. So this is what we call Grimes CSR theory. The person who actually proposed it is known as Grimes. So the C means competitors. So some plants are called competitors. They maximize the capture of resources in productive and undisturbed environments. This could be the conservation agriculture CA systems, where we are promoting less disturbance, but we are creating good conditions for plants by increasing soil fertility, putting water in the environment. So we have got abundant during the early and intermediate stages of succession. So we have got stress tolerant plants. These are the S plants. These are the long-lived plants adapted for conditions of limited productivity. Occupy last stages of succession. Probably this is the vegetation which we see as forests and grasslands in undisturbed areas. The ruderals, these are the short-lived herbs with the high seed production and occupy the earliest stages of succession. These are actually the weeds. So here we've got weeds. These are the ruderals. Here we may also find weeds, but probably not here. This could be conservation agriculture or Pfumvudza. This could be conventionally tilled plots. And the grime had to represent the relationship of environment, where you have intensity of stress and intensity of disturbance using this triangle. It has got the bottom part, which is a relative intensity of stress going this direction. Here is a relative intensity of competition going this direction, and the relative of intensity of disturbance going this direction. When everything is put together, we come up with, at the top of the triangle, we have got the competitors. Probably this is what you find in CA. And here you find the stable environment, where we find the stress tolerant species. These are they occupy this corner. So if you draw a triangle, at the top there are competitors. On your left, S. This is S, representing stress tolerant species. And at the right corner there, you have the ruderals, which are weeds. Depending on the environment, you get various combinations in between. When you do your analysis using that I think somebody is trying to get in. Okay, you are in. Let me go back. Right, so there are three areas. We have got the competitors, which could be, this could actually be weeds. Right? A lot of people are coming in now. Okay. So where we have at the top, we can find the weeds. Here we can also find the weeds. But this is the, these are the forests and the grasslands. They are plants but not weeds. Right? This could be grazing areas and so on. And in between, depending on how we are disturbing the environment, we get something in between the triangle. But we are not worried about it, but we can use Grimes' approach to find the place of weeds within the environment. And I think I will stop here and go to something else.